Morning guys, welcome back. Oh sorry, I just moved my breakfast. Okay, here's my hands again, looking a lot drier than they were before. Lots of good hand washing going on. Hope you're all well and keeping safe. And here's my next attempt at some teaching via the medium of YouTube. So today I'm going to talk to you about polygenic inheritance. But before we do that, just need to recap on where we are. Okay, what you know so far is monohybrid inheritance. And what monohybrid inheritance talks about is the idea that there is a characteristic which is controlled by an allele at one position or one locus on one particular chromosome. So, for instance, here. Now, if two people like that with the same genotype breed, we separate that into the gametes. So this person can either produce big B gametes or small b gametes. And we have this sort of thing going on. All right. Now, therefore, we can get offspring as such. Now, we've worked on a dominance idea, so this would be 75% brown, 25% blue. Even if we had something called co-dominance going on, which is where both alleles contribute to the characteristic, to the phenotype, we'd still have brown, blue, and somewhere in between the two. So that would still only give us 3 different potential phenotypes for eye colour. Now you guys always ask this to low down the school, well, I've got green eyes or I've got slightly less brown eyes, and you get very different answers for your teacher, because at that point you don't necessarily need to know that much. So what we're going to show you today is that, you know, you're not necessarily a mutant because you've got slightly different eyes, okay, is that this can work. So that's monohybrid inheritance. Let's rub that out. Now, we're going to do an example of skin colour. And as you know, the kind of shades of skin colour are kind of indefinite, really. And they're controlled from your work yesterday by a pigment called melanin, which is added to the skin often as an environmental, in response to an environmental stimulus, and makes the skin darker and protects it from the UV radiation. Now again, we're going to make this relatively easy compared to what it might be in reality, because we're just going to use 2 alleles at 2 loci. So let's imagine this is, I don't know, chromosome number 3, and on there, at a particular position, particular loci, we've got an allele for skin colour, and this person's heterozygous. Then at chromosome number 17, there's a different allele, and again, this person's heterozygous, but it's a different allele, so it's got a different letter. Now, let's think about what gametes that person can produce, because I think this is where people overlook this in monohybrid inheritance. As I mentioned earlier, when you split those alleles, you're basically doing meiosis. So let's think about what this person could produce during meiosis. If we split that in half, i.e. making a haploid cell, that gives us that potential gamete, okay? But remember, we've got independent assortment going on, okay? So we can actually get any of those combinations, all right? What we can't get is that, or that, because they're on the same chromosomes and they're gonna split, okay? But what we can get is potentially that, potentially that, and then potentially that. Okay, and that gives us the 4 different gametes that this, let's say this is the male can produce. Okay, now let's again make this more straightforward and just say that that male has somehow found himself a wife who has got exactly the same genotype. All right, so she is able to produce the same gametes. So there's the gametes that are produced in this situation. I'm just going to do a few of them and then you can do the rest yourself. But if we just do this top corner one, big A, big A, big B, big B. If we go into the bottom corner here, all recessive alleles there, and we'll just pick a random one in the middle, Let's go there. A, B, B. Now, that gives us all of our different genotypes, and you can have a look at that and see how many different genotypes we are able to get with that situation. But we also need to see how this works in terms of the phenotype. So what we're going to say here with skin colour is that any dominant allele adds melanin. Okay? Any dominant allele adds melanin. And when we add melanin, that makes the skin darker. So this person here, this person, all of their alleles are adding melanin, so this person is going to have very dark skin. This person down here, I wouldn't be advising to go in the sun because none of their alleles are adding melanin, so they're going to be very, very light skinned. And this person here, okay, it's got two alleles, the two A's are not adding any melanin, but the two B's are adding melanin, so you're going to have somewhere in between the dark and the light. And as you work your way around this grid, you'll be able to see that there's various different shades. Okay, and that is polygenic inheritance, and that is why we have much more variation in the phenotypes than would happen with monohybrid inheritance. Okay, and in reality, most characteristics are polygenic, and also they're not just going to be controlled by two alleles. We could be in the tens of alleles, if not more. Okay. Now in your books, for the work I've set you, there's an example where you've got to work with 3 loci. All right, so that's going to make things even trickier, and you should be able to come up with more characteristics. And then obviously the other thing we've got to talk about here is that you throw the environment into the mix, and you know the potential phenotypes change again. All right, but this is polygenic inheritance. Any questions, give me an email. I hope you're all keeping well, and thank you for spending your morning in my kitchen. Goodbye.